So hello and welcome back. So in this video we want to, I guess it is the second of those problems that we were talking about. So the question is, a newborn calf weighs 40 kilograms. Each week its weight increases by 5%. So let W be the weight in kilogram of the calf after t weeks. Is W a linear function or an exponential function? So this is basically a good example or a good problem where you can understand the difference, the practical difference between a linear function and an exponential function. So how that works is that, let me see. Okay, so we could start with a table. So if we have a table like this for the basically, okay, so if this is so the calf weighs 40 kilograms, so the weight of the calf is already 40 kilograms, and each week its weight increases by 5%. So if this is week 0 right now it is 40 kilograms, and this is I don't know, let's call this n, for example, n as the number of weeks or something like that. So every week, each week, its weight increases by 5%. So that means there is an increase of 5% of this weight after 1 week. So this is week 0, then you have week 1, and then you have 40 times 1.05. So it is 40 times 1.05. 1 times 1.05 means that you have increased the weight of basically you have increased 40 by 5%. If you have an increase of and how you can get this number, you don't need to memorize it or anything. So an increase of 5% means that the 40 kilograms of weight was you add 5% of 40 to 40. So 40 plus 40 times 5% of, or let's write it this way, 5 times 40% of 5, I'm sorry, 5% of 40, 5% of 40, so it is 5 by 100. So this is 5% of 40. So I add 5% of 40 to 40. So that is basically an increase of 40%. I'm sorry, an increase of, I'm kind of confused here, increase of 5%. Now if it was an increase of a decrease of 5% of the same amount, it would be 40 minus 40 times 5 divided by 100. 5 divided by 100 is basically nothing but 5%. Now in this case, an increase of 5%, you can simplify this by taking the 40 out, and then you get 1 plus 5 divided by 100. And then you can take this 1 as 100 by 100. You can rewrite this as 40 times 100 by 100, which is 1, plus 5 by 100, and this will be 40 times 105 by 100. So then what happens here is that 105 by 100 is basically 40 times 105 by 100 is 1.05. 1.05 is nothing but 105 divided by 100. So an increase of 5%, which we began here, 40 plus 40 times 5 by 100. If you simplify, you get this expression, 40 times 1.05. And this is basically the same thing that I have written over here. Now, a decrease of 40% is nothing but times 0. A decrease of 40%. Let's see what that becomes. I have actually forgotten that. So let's see if you have 40 minus 40 times 5 by 100, you can take a 40 out. This becomes 1 minus 5 by 100, and then you can rewrite this as 40 times 100 by 100 minus 5 by 100, and then that becomes 95 by 100. So 40 times 95 by 100, and 95 by 100 is nothing but, this whole thing is 0.95. So 40 times 0.95 is a decrease of 5% of 40. So whatever remains is 40 times 0.95. So if it was a decrease of, let's say, 10%, it would be then a decrease of let's say 10%, then it would be 40. And if the amount was 40, so a decrease of 10% of 40 would be 40 times 100 minus 10, which would be 90, and so 90%. And that's how basically you do all of those things. So basically here we learned that if you increase 40 by 5%, you will get 40 times 1.05. Do not forget the 1 part. So, and then let me erase all this. Okay. So now what we are doing here, so that we said that each week its weight increases by 5%. So after 1 week, you have 40 times 1.05. After 2 weeks, you have this amount increased by 5%. So it becomes 40 times 1.05 times 1.05. And so you can see that this is equal to, and then after the after 3 weeks, it will become 40 times, again, this amount times 1.05, because you want to increase it by 5%. So 1.05 times 1.05, and then again times 1.05. So you can see a factor of 1.05 that corresponds to this, that corresponds to this number here. So you have 1 factor here, 2 factors here, and 3 factors here. And here you have a so basically after n weeks, you have 40 times 1.05. so this is basically, you can rewrite this as 40 times 1.05 raised to the first power. You can rewrite this as 40 times 1.05 raised to the 0th power. So because this is 1 and then it becomes 40. So this is 1.05 times, or no, sorry. So this is actually 40 times 1.05 to the second power. To the second power. And this is 40 times 1.05 to the third power. And so this is simply 40 times 1.05 to the nth power. Now, and you can see that here I have an exponential function, and this becomes your a, this becomes your b, and you remember that we had as a general form of an exponential function f of x is equal to a times b raised to the power x. So now we have, of course, now we know that it's an exponential function, but we still need to talk about linear functions and how a linear function is different from this function. Of course, we have done that in the previous videos, but it's still beneficial to compare such two cases and see how these two types of functions differ. So basically, how a linear function is different from this function, from this exponential function, is that, let's say, I should have called this as w of n is a function of n, for example. So basically, let's consider another function. We still have all of these over here. Let's say you have a linear function like this. A linear function like this. It seems I'm not very good at drawing straight lines. It's not easy, believe me. So you have this linear function, and let's say we have the y-intercept of this function is y is equal to 3, and then the slope of the function is 2. So your rise over run is equal to 2. That means for every unit of run, you are, that is 2 divided by 1, of course, or 2. So that means for every unit of run, you have 2 units of rise. That means if I want to draw this function, that means if, let's say this is 1, 2, 3. So for 1 unit of run, that means 1 up to here, 1 unit of run means 1 unit of horizontal change in the input. I have 2 units of rise in the 2 units of vertical rise in the output. So I have 3, 4, 5, let's say. So I have 2 units of rise here, so that the other point comes over here. So one, to get from this point to this point, for each unit of run, I have 2 units of rise. So this is 1, this is 2 units, based on this coordinate system. So then my function becomes something like this. Okay. my function becomes something like this. Now, you can see that for each unit of right here, I'm running out of time here, so I have to do the rest of this in the next video. Thank you.